Welcome everybody. This is Dr. Wilson, and this will be our video for the week, and it will discuss solving systems of equations by use of the method of substitution. So we looked at graphing last week, and this week we'll look at substitution. So you'll find all these questions that I'm looking at today in the Exam 3 folder. So look for the presentation, look for this video, and you will see an assessment attached to your email later today. So let's get started. This is definitely a system because we're looking at 2-point questions and we're looking at 5-point questions. So we're going to say X is the 2-point and Y are the 5-point questions. All right, what do we know? Well, we know we've got an exam that's worth 145 points, and since these are involving points, we're going to have 2 times X plus 5 times Y. So if we knew how many questions for X and Y, we would multiply by 2, multiply by 5, we'd add together, we should get 145 points. We also know that we have 50 questions total, which means we've got so many 2-pointers plus so many 5-pointers. So here's our system of equations, two or more equations, and this satisfies definition of a system. So with substitution, our goal is to find one of the equations that has a coefficient of 1, and this equation right here fits that. Doesn't matter if you solve for X or Y. In this case, I'm just going to solve for Y, and I'm going to subtract the X. So I get Y is equal to 50 minus X. Where does that 50 minus X go? Well, if that's what Y equals, then it's going to substitute right in there for Y. So down here I'm going to rewrite 145 equals 2X plus 5, not times Y anymore, but times 50 minus X. I'm going to distribute the 5, and I get 145 equals 2X plus 250 minus 5X. So again, now I'm in one variable, just X's, so I can definitely solve this one. So I'm going to go ahead and combine these two, and that's going to give me negative 3X, and I've got 145 equals positive 250. So what I'm going to do is just add the 3X over here and subtract the 145. So I'm going to get 3X plus 145 equals 250. And then I'm going to subtract 145. And I'm going to get 3X is equal to 105. And then, of course, divide by 3. What does that give us? That's going to give us the number of 2-point questions, which is 35. And we're not finished. Since we know X is 35, basically we want to take it right up here and we want to substitute since, oops, my pen drags sometimes. That 35 will substitute in for X. So now you get, for Y, it's going to be 50 minus 35, which Y would be 15. So your ordered pair, your solution would be 35, comma, 15. And that means something. 35 represents how many 2-point questions we have, and 15 represents how many 5-point questions we have. So I encourage you as you look through the videos to replay them, stop them, pause it, try to work through it, and see how you're doing with it. So let's look at the next problem. The Lakers scored a total of 80 points in a basketball game against the Bulls. Lakers made a total of 37 2-points and 3 points. So I'm going to call X to be the 2-point shots, and Y would be my 3-point shots. The Lakers made a total of 37 2- and 3-point baskets. So 37 is equal to X plus Y because we've got so many 2-pointers and so many 3-pointers. And then we scored 80 points. So 80 would equal 2 times however many 2-point shots, and 3 times however many 3-point shot. So here's our system of equations. This one lends itself very nice to solve for x or y. So I'm just going to solve for y, and that will give 37, and I'm going to subtract the x, so I get y is equal to 37 minus x. So where I see y in the second equation, y disappears, and what is substituted in is 37 minus x, hence the name substitution method. So we've got 80 equals 2x plus 3 times 37 minus x. We're going to distribute, and I'm going to get 80 equals 2x plus, and 3 times 37, I get 111 minus 3x, and I want to combine these two, so I get negative x plus 111 equals 80, and I'm just going to make my variables positive, so I'm going to get x plus 80 equals 111, and I'm going to subtract 80, and I get x to equal 31. What does that mean? Well, x was equal to 2-point baskets, so we had 31 2-point baskets. So if I know what x is, and it's 31, then I'm going to substitute right back in here. So that would be 37 minus 31, and what does that give me? That gives me 6. So my solution would be 31 comma 6. 31 meaning how many 2-point baskets, 6 meaning how many 3-point baskets. All right, let's look at another one. School that Stefan goes to selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizens and children. So I'm going to say x is senior and y would be children. So the first equation, we're dealing with days. We got a day 1, and looks like on the first day and then the second day. So it looks like we've got 2 days here, so each equation would represent different days. So first day we have 3 senior plus 1 child. How much did they make from that? They made $38. Second day they had 3 senior and they had 2 children and they made $52. So here's my system. This equation lends itself to solve for, or has a coefficient of 1. Second equation does not. This one has a coefficient of 1, so that's a whole lot easier to use our substitution method. So I'm going to solve the top equation for y. So y equals, and I'm going to subtract the 3x to the other side, and I get 3x minus 38, or maybe some of you wrote 38 minus 3x, either way. So what am I going to do? Well, I know y is equal to this, so wherever I see a y in the second equation, I'm going to substitute. So I get 3x plus 2 times 38 minus 3x is equal to 52. See a lot of patterns here with the substitute and then the distribute. So 3x plus was 76 minus 6x is equal to 52. And again, I want to combine my coefficients, my like terms, and that's going to give me negative 3x plus 76 is equal to 52. And I'm going to add the variable to the other side, and then I'm going to subtract 52 all in one step. So that goes to 0 here, that goes to 0. So I'm left with, what do I have, 76, take away, so that's going to be 24 equals 3x, so x is equal to 8. Well, if x is equal to 8, then I'm going to come right back up here, and then I know y is going to be 38 minus 3 times 8, which is 24, and then that should give me 14 as y. So my solution would be 8, 14. What does 8 mean? Well, 8 means the number of seniors at the top, and 14 means the number of children. It asks find the price of the senior citizen ticket and the price of the child ticket. So this 8 is just $8 for the senior ticket. 14 would be $14 for the children's ticket. All right, let's look at another one, and then I'll run out of my time on this. But here, there's no context to it. But when you're looking at a system like this, notice that, well, y is already solved. So if I take my second equation, if I already know that y is equal to negative 3x minus 5, then I want to do the substitution. So I get negative 3x plus 5, and that's equal to negative 3. So that was nice because on part A here, it's already solved for y, so I know what to substitute. So 5x, negative 4 times a negative 3x would be a positive 12x. Negative 4 times a positive 5 would be a negative 20, equals negative 3. So if I combine, I'm going to get 17x minus 20 equals negative 3. And then I'm going to add 20. And that should be a 20. And that's going to be negative 3 plus 20 is 17. That goes to 0. I'm left with 17x. And if 17x equals 17, x has to be 1. So since I know x is 1, I'm going to substitute right back here. And so y would be negative 3 times 1 plus 5, or negative 3 plus 5, or y is equal to 2. So 1 comma 2 would be the solution. No context, and so that would be our solution. So on the second one, we've got y is equal to, so part B, y is equal to 5x minus 7. Again, this sets up very nice because we know what y is. And wherever I see a y in the second equation, I'm substituting 5x minus 7. And then I'm going to solve. So I get negative 3x minus 10x plus 14 equals negative 12. And so this would be negative 13x plus 14 equals negative 12. So if I subtract 14, I'm going to get negative 13x is equal to negative 26. And negative 26 divided by negative 13 gives me x is equal to 2. So if x is equal to 2, and remember I'm coming right back over here, so y is going to be 5 times 2 minus 7, or 10 minus 7, so y is equal to 3. So that means our solution would be 2, 3. All right, I want to encourage you to go back and try to work some of these by yourself. I want to encourage you to go to some of the practice links in the presentation where there's several examples to practice, and look for a quiz. Quiz 7, Quiz 8, they'll be attached. It'll be half sheets of paper, one sheet, one quiz on the top, one quiz on the bottom, where one quiz will be looking at graphing and the other one will be working with substitution. So I'd like for you to either print that off or copy it on paper and bring it in next Tuesday. Y'all have a great week, and miss you guys, and I'll look forward to seeing you in a week. Thank you.